All of us use decimal counting system 0 to 9, units, tens, hundreds, and so on. The question naturally arises that why do we use decimal system? Well, the answer must be that it is the most natural system because humans historically counted using their 10 fingers. Secondly, it is widely used in daily life for counting money and measurements, etc., etc. What are other systems? Other binary system. There is a binary system which is zeros and ones. Then there's an octal number system, which is base 8. And then hexadecimal system, which is base 16. Let's look at the binary number system, base 2. Let's first see how binary numbers are written in comparison to decimal numbers. So we do them side by side. So if I can write decimal and then binary on the right hand side. The decimal systems we all know goes 0, 1, 2, 3, and so on to 9, and then he goes to 10. And then 11, 12, 13, and then when he reaches the 99, then he becomes 100, becomes 3 digits. And when he becomes 999, we go to 1000. Similarly, binary system also works similar, but only because it has got 0 and 1 digits only, whereas decimal moves between 0 and 9. So the first we write is 0, 1, and then first is 0, 0, and then 0, 1, and then 1, 0, and then 1, 1. And after that, because they become 2, 1, now we move to the next digit, becomes that, and then carries on with that, that, and then all goes 1, 1, 1, 1, 1, 1. When they all go 1, 1, 1, and then we move one more digit there. And then it goes 1, 0, 0, 1. And then 1, 0, 1, 0. And then 1, 0, 1, 1. And then this 1. And then the third digit becomes 1, and those go to zeros. And then goes 1, 1, 0, 1, 0, 1. And then after that, that becomes 1, 1, 1, 0. And then 1, 1, 1. And then 1, 1, 1, 1. Yeah. So that's how they carry on going. But if you look at the first one, the first represents 0. Well, let's move it one digit to the right. So it'll be 0 in decimals. Decimal equivalent now is 0, and that's 1. And that is 2, 3, 4, 5, 6, 9, 10, 11, 14, and 15. Yeah, that's how these numbers move. Okay, fill all the 4 columns now. Where there's no number, there are zeros. Zeros. And if you look at fill zeros, zeros. And if you look at the first column, one all the way up, down, and then the second column is 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. And the third column is 4 zeros, 4 ones, 4 zeros, 4 1. And then fourth column, 8 zeros and 8 ones. See, that's, and if it was next column, then it'll be 16 zeros and 16 ones. Okay, how do we evaluate, how we convert them into decimal, see how they work. So if we write at the first column 2 to the power 0, second column 2 to the power 1, and third column 2 to the power 2, and the fourth column 2 to the power 3. Now, any 0 answer is always 1. If I say 8 to the power 0, it is 1. 3 to the power 0, it is 1. Any number to the power 0 is always 1. Right, now let's work out the numbers, how do they work. And 2 to the power 1 will be 2. And 2 to the power 2 will be 4. 2 to the power 3 will be 8. And 2 to the power 4 will be 16. And they all go like that. So if we can move them, leave them out, and we go up and check the first zeros are all, anyway 0. And if we look at this one, only there's a 1 in the first column, which means 2 to the power 0. That answer will be 1. And the second column, 2 to the power 0 is already 0, nothing. But the 2 to the power 1 is 2, there's 1, so it'll be 2. And then third column, so it's in both columns there's 1. 2 to the power 1 is 1, and 2 to the power 0 is 1. So that'll be 3. So on. If we look at the 8, so it's the fourth column, which is 2 to the power 3. So 2 to the power 3 will be 2 to the 4, 8. So that's that. And similarly, if we look at 13, so we have 2 to the power 3, 2 to the power 2, and 2 to the power 0. So 2 to the power 3 will be 8, plus 2 to the power 2 will be 4, and 2 to the power 0 will be 1, which will be equal to 13. And that's where 13 comes in. So same as for the 15. If you look at the 15, so first is 8, 2 to the power 3, 8 plus 2 to the power 4 plus 2 plus 1. So this makes it 15. Yeah? Now, if we are given the decimal number, how do we work out the equivalent binary number? So we write the number, say for example, we are given 16 to write. So we draw a line there, and then we divide by 2. So it'll be 8 2s are 16, remainder 0. And then 2 4 2s are 8, remainder 0. And then 2 2s are 4, remainder 0. And then 2 answer 1s, 1 2, and then remainder 0. So now the answer now is we go and write like this. So it will be 1 0 0 0 0. Remember that after 15 it moves to the next column. So we won't have 4, now it's 5. So that's how you do that. Let's do one more, 73. So if we do 73, so 2 divided by 2 will be remainder 1, and then 2, 18, remainder 0, 2, 9, remainder 0, 2, 4 2s are 8, remainder 1 now. And then 2 again, it'll be 2 2s are 4, remainder 0. And then 2, 1, 2, remainder 0. So 73 will be, if we go this way, so it's 1 0 0 1 0 0 1 1 0 0 1 0 0 1. So this will be 2 to the power 0, 1 2 3 4 5 and 6. 0 1 2 3 4 5 6. So that'll be 6. 2 to the power 6, 64. And this is 2 to the power 4, which is 8. And this is 2 to the power 0, which is 1. So when we add them together, the answer is 73. Okay, that's how we convert them into binary, from decimal to binary. I'm going to give you some questions so you can figure out homework. And you can give us the answer in the comment section. Okay, so you can do convert into decimal. 0 1 1 1. That's number 1. Number 2 is 1 0 1 1 0 0 1. So this is a 7-digit number you can answer. Okay, and we will look at the octal system, next octal and hexagon, in the next video. And if you haven't subscribed this channel, please subscribe. And I hope you will learn the binary system. And thank you for watching.